Okay, so we're starting today's session, and we are going to begin from where we began in the catch-up session. So in the catch-up session, we were looking at something new, but something we've been using, but maybe we've not actually looked into the details of it. So each time we created a server or an EC2 instance, we made some choices, right? According to, in terms of the area or the private network where we want to deploy this server. So AWS Cloud gives you, okay, the ability to create your services, that is some services, in a secured network that no one can access apart from yourself, who is the owner of that account. And we call this one the virtual private cloud. That's the VPC, the virtual private. Okay. Now, with the VPC, it's not all the services on AWS that we deploy to a VPC. So that's one of the key things that we mentioned. Great. So with the servers or the EC2 servers, when we deploy, we definitely deploy them into a VPC, a virtual private cloud. And these VPCs, as I said, mentioned earlier, it gives us the ability to place servers either in a public or private location.
Hello.
Sorry, team, I had an interaction over there. Okay. I hope my voice is audible enough. Let me check the chat. Okay, good. So someone say they can't hear me at all, but I think it's coming from your device. So Classify, kindly be responding to some of the messages in the chat for me, okay? I can't be looking in the chat and looking here at the same time. Okay, great. So let's just get started. So we're looking at the VPC architecture again. When we say VPC, what do we mean? That private network within the cloud, okay, our AWS account where we're able to deploy or create services into, right? So that no one has access to any of those services or computers, whether they are servers hosting our website, servers hosting our database.
The only one who can't hear
We don't
anything.
give.
Get into the conversation.
I've muted everyone. Please, if you have any concern, just put in the chat. So we'll look at that quickly. Then the next one is we look at routing and gateways. This we'll talk about in a little more depth today. Actually, we'll actually do a hands-on, so I have to really go fast today. Then we'll deploy an EC2, of course, into the VPC we create. Then we'll look at some few architecture patterns that I usually use, right? Then we'll also talk about certain security layers to protect our services or servers deployed into the VPC. Awesome. So let's just get started without wasting time. Okay, so this is how a VPC looks like. And this is how we depict a VPC with. So what you see here on my right hand, that is this short dashed line. This represents the virtual private cloud we have created, right? So when you create the AWS account, there's usually one default one. Default means it is done for you. So usually there's a default VPC or virtual private cloud, but you can also decide to create one for yourself. So let's assume this one that has been created by us, right? So this is the VPC we've created. Then we mentioned some few things about this VPC or what we are seeing here. So the VPC is not a rectangle in real life. This is just, these shapes are just used to just give us a mental idea of what we are doing, right? So when you ask what's a VPC, don't say it's a rectangular box. No. These boxes are just depict an area, okay, or a space. Good. So we create this unique space for ourselves and then we deploy services or servers there. Okay. And take note, I always want to repeat this, this statement, that it's not every service that is deployed into a VPC. Some of them are deployed, some of them. For instance, the EC2, as I said, it is deployed into a VPC. RDS, VPC. Elastic Cache, RDS is like a database, right? Relational database service. It deployed into a VPC. Elastic Cache, also VPC. Lambda, it is optional. You can either deploy into a VPC or not. Elastic Container Service, VPC. Redshift, VPC. EMR, VPC, right? But some of the services that are not inside VPC, one of them that we looked at is S3 buckets. So S3 buckets is not deployed inside the VPC. DynamoDB is also not deployed inside the VPC. That's a NoSQL database. SQS, SNS, that's a simple notification service, simple queue service. Both of them not VPC. CloudFront, not VPC, right? And the list goes on and on. IAM, okay, what we use to create your users and user accounts, also not deployed into a VPC. API gateway, also not for VPC. So just get that idea that it's not everything we place in a VPC. And I'll give you notes, so don't worry. I'll give you notes. Okay. Let's continue. So, number one, when you want to deploy services in a private area, you create a VPC for that. Now, I've made a simple analogy. VPC can be thought of as a plot of land, a very huge plot where you want to build your real estate building. So if you want to go into real estate, you must know the number of houses that you are planning for. Okay, that's what we call the capacity. And that's why we use this CIDR, CIDR, classless interdomain route. Yeah. This number here is just telling us. It's just telling us capacity. And you see this number, all of these numbers you see inside here, we'll talk about them today. They mean capacity, right? So they just tell us how many computers or servers we can deploy in this whole VPC. So the VPC itself has a capacity. Then within the VPC, we also demarcate. It's like you have your land within that big plot for your real estate. We have demarcated it into two main zones. So that we are using the availability zone of AWS for that demarcation, right? And we all know what availability zones are. We start from regions, the very broad one. We break down regions, we get what? Availability zones. Then we break down availability zones. What do we get? We get data centers, right? So we say that a group of data centers, okay, come together to give us what? An availability zone. Then availability zones to come together to give us what? A region. Okay, so when you create your VPC, there are availability zones within that VPC. And we can create smaller networks, which we call subnets, right? And usually we tag them with two major or two, let's say, two names. Either it's a public subnet or it's a private subnet. So these are the features or typical features of a VPC. Now, when you create this VPC, as I mentioned, it is close to the external AWS network or the internet. There's no connection whatsoever between this VPC and its content and the internet. The only way by which you can allow your VPC to have access to the internet is by just providing a gate, just like a real estate environment, right? If you want to be able to, for people to get inside your real estate compound or your gated community, you must provide a gate. And you see, we have a gate here. So this is our gate. We call the internet gateway. Once you provision an internet gateway and you attach it to your VPC, you are giving internet access, or you are providing a way for the external internet to have access to your VPC, and also for the things in your VPC to have access to the external internet, right? It's like giving your house a router. If there's no router, how do you get internet? You can't get internet. You just be typing www in on your computer and nothing will happen. Okay, great. Now, we don't call these people private for fun. We call them private before because we want to have extra protection for the kind of servers we place inside this subnetwork. So the subnetwork called private subnet, we put our database servers here, right, inside the private, and we give it extra security so that even though there's internet access, doesn't mean that a hacker can get access to this me drawing my hacker here. Can a hacker get access to what? Every device, everything inside here, or not even a hacker, but the external world, right? Can people access all the servers? And the simple answer is no. We prevent people from having direct access or communication with the database servers. That's why we are placing them in the private place. Because these servers, we call the database servers, they may be holding very confidential information. In case, let's just assume you are creating this for a bank, or we are deploying this solution for a bank or for a hospital. These two institutions, there are so many regulations and data protection and compliance rules that govern them. So you can't just put their database in a public area where everybody can access it. No. So to provide that level of security, that is why we are provisioning them inside a private subnetwork. But we may have a website we want everyone outside to be able to communicate with. So typically, the servers that will host these websites for us, right? That we want even customers of the hospital or the bank to be able to access those websites. We'll place those servers in the public subnets so that when they hit www on their laptops, they can access what? Those servers, right? Because there's a connection between their computer to the gateway, then the gateway to what? The servers in a public subnet. Good. Now, when they are providing their information, let's say the people who are clients to the hospital, they provide their information. Maybe you've allowed them to be able to log into their portal or the internet and then book an appointment or check their lab results, blah, 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 on your web service, right? And even with this, as I said, there's no direct communication between the web server, okay, I'm sorry, the database server and their computers, right? The only way they can access their data is through the web servers. And how will that happen? We will create a private connection between these two subnetworks so that the database server can connect to what? The web server. So the only one who can connect and communicate with the web server, sorry, the database server, is the web server. Good. So that no one can just hack into the database server and get people's data, but rather you must be authenticated by the web server before you have access to your unique information stored in the database. So this is just like a general rough sketch of how a VPC may be used. So I've just given a very simple scenario, and our case is just a case of either a hospital or a bank, right? Awesome. Great. Any questions for me? Any questions for me? Today we have to run a little. So I'm opening the chat for questions. So drop your questions in the chat and let's look at them. Okay, so there are no questions for me, meaning that I hope we are all okay. Great, so let's move on to the next slide. Okay, there's a question in the chat. Yeah, we're coming there. Okay, so I'll add one more thing and then I'll use that to explain the hospital scenario again. So now we imagine we have a database server. Servers are just computers, right? So every computer, like your own computer or laptop at home, once in a while you get a message on it that you need to update, right? You need to update the Windows or you need to update certain softwares, and then you click on update. Then it connects to the internet and begin to pull the updates for you, right? Either there are vulnerability updates, like patches that has to be done or whatever it is. Because sometimes those who create the software, they realize that there are some weaknesses in the software that hackers can take advantage of. So when they find those kind of weaknesses, they try to strengthen those places, right? And that's why they create the updates. So that when you click on update, you pull in the new solidified or hardened software which can withstand attempts to be hacked, right? And that's what we do with the update. So let's say you put a computer inside this private network. How then do we update this computer? Because as I said, when you put something in private, it's assumed you are trying to prevent it from having internet access. So we create another device or make use of another device called the NAT gateway, right? The NAT gateway, NAT. Okay. Oh, this pencil is not working. So it's just NAT, NAT gateway. Now, what this NAT gateway does is that it offers another level of what? Protection, okay, for this very computer. So sort of what we discussed even in the character is that it sort of hides its address. And even talking about address, we'll come to look at it as I said today. All the addresses we are creating here, these addresses, okay, that we are calling the capacity of this VPC, right? So we just beforehand, we can go to Ghana Post and tell them we need about 100 addresses because we are going to build 100 homes in our real estate. So that's what we do here. Now, but these addresses, one funny thing about them is that they are just private addresses. These addresses themselves are not even known on the internet. So when you type this address directly on your browser, in your browser, you will not have any result coming out, right? You won't have any result coming out. There are some addresses that look just like this. When you type it in the browser, you have a result. Let me see if I can find some of them. Oh, hold on. I want to share another. Let me see. So I hope you can see my screen. What is this one? I always forget this IP address of Google. 8.8.8.8. Are they sure? It's been a long time I checked this thing. Let's just try it and see. 8.8.8.8. Does it route to Google? Okay, yeah. So at least it's connecting us to Google, right? So let's just assume this 8.8.8.8. So these addresses are not meant for human beings. You see, every website has this kind of address. That's the simplest explanation I can give to you, right? Every website has this kind of address. But this kind of address, because it will be difficult to memorize these addresses, myself, I even forgot, even though it's so simple, 8888. So almost every website you are seeing on the internet, this is their real address. This is how their addresses are written. But we provide a domain name. So the domain name server tries to convert or try to connect these kind of address, which may be difficult to remember, to the normal google.com kind of names, right? So that these ones are human readable, we can remember, right? This one works with us more than the numbers. Okay. So what I mean is that the address over here, this 10.0.0.0, if you type it in your browser or any of the addresses that you are seeing here, if you type them in your browser, the internet will tell you it doesn't know them. So these are just addresses that are known only within the VPC. They are known only within the VPC. right? And they are used to communication between computers within the VPC. So when you are sending a message outside to the external internet, okay, the internet gateway will now offer a new address through which it will be used, and that address will be used to communicate to the external internet. As I said, those things may be too technical, and I don't want us to go too much into them. But just note that all the addresses here, the reason why I'm saying this is that we may create another VPC somewhere, and we will still use the same capacity range. And you'll be like, why is that this address is used here? I'm also using the same address within another VPC. Just because these addresses are only local addresses. They are not externally known. They are only used within the VPC. I hope that makes sense. Okay, great. So now, the NAT gateway, let me come back to that. So as I said, it is still, even though there's still obscurity for all the addresses here in a way, through the internet gateway, but we are giving this extra level of security to the private subnet addresses, right? So when you are in a private subnet, you want to communicate to the external internet, you must do that through the NAT gateway. So you go through two layers, NAT gateway before internet gateway. And this offers only a one-way initialization of communication. So communication can only begin from the private network to the external internet. So when I need to update my laptop in the private subnet, I can do so through the NAT gateway. But if someone wants to connect from the outside to my private server in a private network, this NAT gateway, it will prevent you from starting the communication. I'm using the right word so that we don't mix the two up. So there's only one person who can start communication to the external internet. That is you in the private subnet. If someone wants to be the one who is originating the communication from the external internet, it will not work. So it's set like a one-way route. It is not 100% one way because if this server wants to, let's say, update its operating system, right? How will the update happen? You definitely have to send a request to wherever that update is. So let's say the update is here on a server around here. So you send this request, it gets to this server. Now, how do you get it? How do you get the update? The update must still come back, right? When the update is coming back, the NAT gateway will not block it because it remembers that a request was sent to this particular server. So when the response is coming, it will not block it. That's why I'm saying that it is not really like 100% one way. But when you are just sitting somewhere outside and you want to start the conversation with this server, it will block you. Unless the server himself begins the conversation with you and requests for something, and you are providing what it has requested for, you cannot begin or initiate a conversation. Okay, now we can break and take questions. So let's get some of these little things out of the way first. So please, those who raise their hands, please raise them again. I think I saw Gideon also. Gideon, Gilbert, oh, it was rather Gilbert, yeah. So Gilbert, I'm going to allow you to unmute yourself. And then you ask your question briefly. Make it very brief. Okay, Gideon. Is it Gideon? Is Gilbert?
Hello, sir.
Yeah, let's go.
My is not a question. It's just a plea. I wanted to plea with my colleagues that have their videos on to kindly turn it off. It's affecting some of us. The internet connection we have is quite slow here. So when it's streaming the video, then data keeps going off, on and off. I just wanted to plead. How?
Okay, it's okay. Please, next person. I don't want us to waste time today. We have a lot to cover.
Okay, Shad, this is Daniel.
Okay, sure, Daniel.
Yeah, so regarding the what you just explained, talking about from the private server to the public through the NAT and then through to the internet gateway and being a one-way communication, so that no one is able to go from the internet gateway directly through to the public to the private. I was asking, so do we need to configure it in the cloud? Do you need to configure it, or is by default all these configurations are done?
That's our second part of the session today.
Okay.
So these are things we create, right? You
Okay.
can create them yourself, yeah.
Right.
So it's coming up today.
Okay, sure. Okay.
Okay, good. Okay, so key thing to remember. I think I can mute everyone again. Right? Let me check the chat. Didn't we computer helps us remember the name of blah blah blah. Okay, yeah. Okay. I don't want to get too confused. Take a policy server like the deputy in the main, blah blah blah. Okay. We'll come to all of these things. Maybe today, maybe do a Bashian host. We'll come to those stuff. Okay, now let me continue. But I want us to get the basics very, very clear in our mind, right? So one more thing. Why did we look at where I placed the NAT gateway? Why didn't I place the NAT gateway in the private network? Who can tell me? I placed the NAT gateway in the public subnet and not inside the private subnet. Who can explain that? I mentioned the catch-up. Some of you could not come to the catch-up, but those who came, who can remember? Yeah, put it in the chat. Okay, you want to unmute. Okay, Syed, go ahead.
Yeah, I guess so. It's able to access internet from from the main internet gateway.
Okay, that's lovely. That's great. So it is as simple as that. If you go, we can make the mistake of placing a NAT gateway inside the private subnet. No one has internet access in the private subnet in the first place. So why should you place the NAT gateway there, right? And why no one has internet access? We are going to realize it very soon. We'll do it at the deployment ourselves. Okay, so when we get there, you realize why it is so. So some of the things, I don't explain them too much here. I feel like as we are growing together in the coming weeks, I'll explain them. Those I have to explain, I'll explain. But those I feel like it will just mess up the class today, I won't explain them today. Okay, so looking here, this is where we summarized everything. So that we speak about the internet gateway, the NAT gateway, and then a route table. So what I will actually do today for you to actually see me or understand better is this. This young man is the one who actually brings us understanding of all the things I've heard about who can come in and who cannot come in.
I shot.
Sorry. Okay. So let's clarify these things quickly. Now, we said our internet gateway, right? It is attached to the VPC, not the subnetworks. They will get really tricky with these kind of stuff in the exams. Enables communication between VPC and the internet. I've explained this one. Stateful return traffic automatically allowed. Now, I've also explained this somehow, right? Even with the NAT gateway. As I said, when you request something from the server on the internet, when the traffic is coming back, why do you block it? Because you are the one who requested for it, right? So that's how the internet gateway also behaves. Now, route entry. Now, when we are creating or when we are trying to attach the internet gateway to any subnetwork, right? How do we make sure that the subnetwork is using the internet gateway that's attached to the VPC? On the internet or within the VPC, when you have this destination, if you say that this is a destination, okay, this address is a destination. This address destination just points to the internet. This 0000/0. When I say that send my information to this destination, it just means the internet. So within our route table, when we are creating a destination entry, right, we'll write the destination address to be this. So whenever we have anything that is going to the external internet, we'll just make it point to the internet gateway. So the internet gateway will handle that particular request for us. So anything going to the internet or external internet, we'll just say, let it go through the internet gateway. That's how we do that configuration. When people heard configuration, some of them just started leaving the class. Please, configuration means nothing, it just means settings. Okay. Required for public subnets to work. Yeah, if you don't attach internet gateway and point the public subnets, direct their internet request to this one, the public subnets themselves will not even have internet access. So this gives us full control of which subnetworks have internet access and which ones shouldn't. Okay, now we are done with this. Let's go to this one. The NAT gateway. Where do we place it? In the public subnet. And this allows our private subnet is access to read the internet, right? I've explained this also. Outbound, right? We only allow it, outbound means going outside. So if you're in a private subnet and you want to send any message outside, NAT gateway will allow you to do so. I've already explained this. Also, this is managed by AWS. You don't have to create your own custom NAT gateway, no. AWS will just give it to you, just attach it and configure it. Configure means what? Set it up, that's all. Okay. Now, we can set up within one availability zone, right? And also we deploy one per availability zone. So when you see that whole availability zone, you don't have to create a NAT gateway like 3 or 4. Just one of them can serve the whole easy for you. All the private networks in the easy, one of them can serve it for you. Great. We are done with this summary. The last one we're looking at is the route table. Route table is nothing strange. It's just a table like this, whereby we have the source, we have the destination, and then the resource, right? Something of this sort. We'll look at it quickly, briefly. So each subnet that we create, all the subnetworks, right, that we create, we must attach a route table to them. We associate a route table to them. Then within the route table, that's where we define all the rules. If you are going here, pass to the internet gateway. If you are going here, pass through the NAT gateway, right? So the route table for the public subnets, we'll just tell the traffic data, if you are going to the internet, pass to the internet gateway. But the route table for the private subnets, we will tell them, if you are going to the internet, pass through the, can you tell me the answer in the chat?
Not gateway.
Yeah, NAT gateway. Okay, good. In fact, you guys have mastered this thing already. Let's just get started. Okay. So these route, look at them. Those addresses, we'll look at them. Okay, thank you all for trying to understand this complex thing. Let's move on. What else we have on the plate? Security groups. Yeah, security groups. We talked about this. I'll talk about them again. So, simple analogy. When you're using a security group, think of him as the security guard at your home. When you're talking about network ACLs, ACLs, think of them as the security guard at the airport, right? Awesome. The security guard at your home, what does he do? He may have been given a sheet provided by yourself of the list of people who should come to the house. Security group. So this is the guy at your home, given a sheet of paper to bounce people who are not allowed to enter your home, right? And Knuckles is the guy at the airport, right? The airport. As I said, I didn't take my art lesson serious. So this is the aeroplane I can draw for you, whether it's a private jet or whatever. So this is the guy at the airport. He also has a list. Now what happens? The guy at the airport, when you are going to New York, he takes your passport, verifies everything. When you are coming back, he will still take your passport. He's stateless. Stateless means he doesn't remember. He doesn't remember anyone because too many people, right? He can't remember who went out. You can't go and tell them, see, I'm the one who went to New York. I came here last Saturday. You saw me. You'll be like, hey, I don't know you from anywhere. Just give me your passport and stop talking. Okay, now the guy, the security guard at your home, when someone is coming inside, he checks his list. If you're allowed to enter, he allows you to go, right? When you are coming out of the house, will he check the list? You write on my index. You don't write it, you keep on writing. I'll just kick you out of the class. I'll humbly kick you out of the class. Okay, so those who are going out, he doesn't have to check again because he remembers those who come in. And that's what we mean by it is stateful. Remembers, it keeps memory. So that's it. Now, the security groups have a smaller scope. They are placed around servers or the computers, right? We define the security group around a server. So we call them SG. But the knuckles, we define them around the whole subnet. So the whole subnet, that's why we place the knuckle, right? The network ACL. We place around the whole subnet, which also holds it. So you can have a whole subnet with knuckles. Then we can have a security group also protecting what? The servers inside the subnet. So that's like the hierarchy over there. Okay, great. So let's look at this. So this one is around instance means computer. This is around the computer, right? Instance level. This one is subnet level. Then return traffic auto allowed. Yes, when you're going outside, we allow you to go. Return traffic is not, this one not automatic allow. We will check you before you go. Allow rules only. This one's allow and what? Deny. Then we'll know what these two mean when we get into the practical part. All rules evaluated together. Rules evaluated lowest number first. Yeah, this one too, the lowest number is evaluated. We'll get to find out what lowest number means. These numbers are assigned when you are creating them. Now, deny all inbound, allow all outbound. I've already explained that, right? If you are coming in, unless you check, you will deny. If you are going out, we allow you to go. This one's allow all inbound and outbound, provided that they are permitted to do so on the list, right? Okay, fine-grained per instance control. This is for every instance control, and this one is for the subnet level. Awesome. I'll pause here so I can ask questions.
Hello, sir.
Yes, go ahead.
Thank you very much. So with somebody like me, I want to know the difference between the subnet and then the server over here. In the hospital, you have a laptop or a computer in the consulting room. You are doing consultations with it. But in the internet that you receive that enables you see the patient's record, like previous medications that were given and all of that, receives the internet from the IT room at the administration. So I want to know, I mean, comparatively with these two scenarios that I just mentioned, which one could stand in for the subnet and then which one could stand in for the, what do you call it? I don't know if you get my question, sir.
Okay, so I get your position. So we create a private network. Then we further demarcate this private network, okay, into what we call subnets means smaller network. That's all. So these are just smaller networks. So they are not actually servers. The servers are the computers we place within these zones. So I have a private zone, I have a public zone. So I can play the server within these zones, either a private or public subnetwork or zone. So that's the idea of the subnets. They are just zones. They are not actually computers themselves. They are just zones that we create. So do you want any clarification again? We can continue and ask.
Okay, it's okay.
It's okay. Okay, good. So with the hospital scenario you are given, see the way we network things in AWS is similar, but may not be like the example you gave of you getting internet access through the server room or something of that sort. That may just be a local area connection that they've created and maybe attach a router to it or so. Yes, but direct connection to the VPC, maybe not now, maybe later on we will find a better example. Yeah.
Okay.
Okay, good. Welcome. Any other questions? Let me check the chat. Okay, let's continue. So I've already explained this scenario, right? So there's an internet gateway, public subnet, and then a private subnet. This is where you put your database, and this is where you put your what? Web server. Okay. So, and the database server cannot be reached from the external internet. And I've already explained all of this. So let's just continue. Next slide. Okay, so there's a project for you guys to work on. So what you guys will do is you'll be building a VPC yourself with public and private subnets across two availability zones. You add a NAT gateway, you provision a bashing host, EC2 web server, simulated database. Don't worry, I'll give you the steps to do these things. I'll make you sweat. I'll give you the steps. So before we continue, let's look at one or two things. Let me give you guys a 2 minute break. Just go grab a cup of water and let's continue. 2 minutes, we'll be back. Are we good for the break? Just type good. 2-3 minutes break. Go and grab a cup of water, walk around, stretch, and come back. Yeah. Okay, we are back. So let's just take some 5 minutes of the time. Just 5 minutes. And then we use the 5 minutes to walk through this whole thing about IP addressing. Just 5 minutes. I'm not spending too much time. If I spend too much time, I'll just end up confusing people. So I'm timing myself. 5 minutes, I should be done. Okay, Daniel, you have a question. Ask a question before I proceed. Daniel, your hand is up.
Okay, sir. Thank you very much, sir. Please,
Okay.
the NAT gateway and then the private server or the private base. I don't know. I want to confirm, but it's like I heard you say that the NAT gateway is already it's something that is actually deployed already on its own by
No,
the AWS. I don't know, or
no,
it's something.
I said the NAT gateway as in the other device itself. You don't
Okay.
create or bring your own. AWS has one. You just pick it and attach it
Okay. Okay. Okay.
or include it here in your architecture.
Okay. And then the second question is, what is it that enables the NAT gateway from blocking the internet access to get to the private? Is there something like a build up in it that actually gives it that
Yes,
capacity?
yes, yes, yes. is all included in its design. So today we are just on a high level, but if you just Google it up, you get the details. Okay.
Okay, thank you.
Yes, yes. Okay. Thank you. Let's continue. So IP addresses, that is how we locate everyone or give anyone an address. Yeah, the word is still address on the internet or on a network. Two things. Internet is like public, right? Network can be private, as I mentioned. Like in the VPC, all the addresses that we are trying to assign or create, they are just private addresses. Okay. So let's just walk through this quickly. So you have an e-commerce company that approaches you and they need a cloud network for their website, right? So they have admin tools, they have a database. They want their servers and their database to be placed in a secured location, right? So that no one on the internet can hack it. And that's what we've already described or explained. So definitely when someone is talking like this, you are thinking of private public subnets, right? Okay. So they have their own website, which is facing the internet. So this one, you put this on, or you place this server on the public subnet. Then their dashboard and admin tools that they want to be isolated. This one can also go into the private subnet, right? Then their database server can also go inside the private subnet. Okay. So now I just want to look at those numbers I just skipped a little, not too deep, but just a little. Now, sorry. Now, these numbers, what do they mean? So this /16, okay. So this is what actually controls the number of endpoints available to be used, right, for our hosts. And the rest of it controls the network address. So the rest of it controls the whole network address. So we can assign this whole thing to the network as a network address. And then depending on what number we place here, we can also control the numbers, okay, or the number of hosts that can be provided. Hosts just means computers that can use the rest of the addresses that are available. Now, when you have a /8, I just made them very simple here, right? A /8 is quite huge, right? So we are thinking of a continent scale, something like 16.7 million, right? 16.7 million, that's like a whole continent, right? So if a service wants to go like to the continent level, provide the services at the continent base, like this kind of number of subscribers or users, then you are thinking about /8. /16 is talking about 65,536, right? Consumers, right? We are thinking of this in terms of a country scale, and /24 is just talking about 256 usable. And then /32 is like, what they're going to use it for? Just one person. Why would they even do that? Okay. So we can use either /16 or /24. These will make sense to us, right? Depending on the kind of business that we are running. Okay. Now we are looking at why /24 gives only 251 usable addresses. So why 251? Because at the end of the day, we expected something like 255, right? So how come it has been reduced? So the first one, okay, one of them will be reserved for the network. One will also be reserved for the router that will be used within the network. One will also be reserved for the domain name server, which does the address translation for us, right? Try to map the names to the IP addresses. Then one will also be used for what? Reserved for AWS future use. So that's why the numbers have reduced from 255 to 251. Okay. As I said, I'm not giving the details. Maybe during the catch-up, we can look at the calculations involved, the bits, and all those kind of stuff. But here, I don't want to do that now. So some of the typical questions that we asked to give us an idea of what range of addresses to provide are what I've listed here. So how many environments will be sharing this VPC? So sometimes when developers are creating a solution, we have 3 environments we create. One is called development, one is called staging, one is called production, right? So if you have 3 environments, based on the environment, we can advise the number of or the CIDR range that you need, whether you need more or less, okay? Then we'll also ask about how many subnets that you're going to create. So someone may say, I want, let's say, just 2 private subnets, right? 1 public, 1 private. Someone may also want about 3 concurrent running in parallel. So let's say you have private, public, another private, public, another private, public. That is about 3 different private, public pairs, right? So all this also informs if you are creating more subnets, definitely you need a wider range, right? Okay. So this is just an example of an architecture that we can provide for the maths that we are dealing with. So we have a production VPC, a staging VPC, and then the development VPC. So as you can see, for development, this is where like we actually write the codes and test everything. So we may just need 2. Maybe the developers are creating the, what do you call it? The web server inside the public and the database over here. But when we go to staging, we may want to put the web server on 2 different subnets and do something we call load balancing. So load balancing is just a way by which we split the traffic between 2 different, let's say, computers, so that when there's a lot of traffic, okay, the traffic gets split up and is handled by the 2 computer pairs so that one computer is not overloaded. But when you are a developer and you are just building the website at the first stage, right? Over there, you are not really doing any stress test. You are just doing design. So you just need one for the web server and one for your database. That's all you need as a software developer or as a software engineer. You let them work in this environment. But over here, this is where you begin to do your testing. You do your test to see whether if the more people are using your web server, whether you can handle the traffic that is coming in. So that's why we try to create like duplicates of what? Of the instances of the web server and of the database. So that when we have more, and we are trying to stress test it or try to create a real world simulation, we will see how our system can handle it. So over here, that's why we have more here than inside the developer. So developer is just one engineer or maybe a few engineers just designing your software or website for you. But here we are no longer designing, we are just testing, right? Then when it comes to production, production is where we actually give users on the internet or everyone access to it's an e-commerce shop, the e-commerce shop that you have built. So it can be something like Jumia or whatever, Jumia or Amazon or whatever, right? So over here, you may want to create what? More of these subnets to deploy more of these servers that you are using to host your application, right? So over here, you can see that these ones may be our main web servers. Right now, I'm just showing you 2, but we can deploy more than 10 of these, right? But this is just an example. So let's say these 2 you are seeing here for the web server and the app server. Okay, app server includes the database. These ones may just represent about, maybe a group of these, right? So you may have 10 of these. Then you may also have the failover in case the main ones are not working well. We can now depend on the secondary ones. And the same thing for the database also. So you may also have created a private database. So when you have a 3-tier like this, sometimes we may call this one a 3-tier architecture, whereby you may have the public web server, then the back end, then the database also. So at least we are spanning over 3 different regions, right? Okay. So the whole idea is that the picture that I want to get from here is that when you are developing, you may need less, right? When you are staging, you may need a little more, but when you are in production, you may need much more. So all of these have to be taken into consideration when you are creating your ranges for your deployment. Okay. So I've already explained some of these ones. And from what we are going to look at in the catch-up, when we start doing the calculations, you realize that some of these things, okay, they are flexible. They are not strict as in /8. They don't move in like multiples of 8, like 8, 16, 24, 32. No. We will learn how to do some of these calculations and arrive at these numbers to meet specific needs. Okay, so this is just a quick overview of how these siders are created or what informs us to create some of these ranges. So depending on the environments that we want to create to develop our solution, to test our solution, and then to deploy our solution, we may need to be aware of some of these environments. And then when we are trying to create these cider ranges, we'll take all of those factors into consideration. Okay, that's that. Now there's one more thing I'll show you before we go on to the practical section. That's just this funny animation I created over here. So let's see whether we can see how this one works. So this is the internet, then your public subnet over here, your private subnet over here. Then within the private subnet, you have your database and your app server. Usually when you think about these two, this is what typically we may call our back end, right? So when you hear developers talking about back end, it usually consists of their API code and then their database itself. So this can have, the app server can host all of your database logic, and then and that may also just connect to what? Your database server. So when I say API logic, it means, okay, don't worry, I'll do a practical session with you on that, maybe one of the catch-ups. But your front end, I think I've explained front end, back end, and database before. So your back end code will be here inside the app server. And this is where your database, whether it's MySQL or DynamoDB or whatever it is. So let's just use MySQL, right? You can put your MySQL server here. Or your PostgreSQL, right? You can put that one here. Then your front end can be inside here, right? Your front end code. Your HTML, CSS, JavaScript can be hosted here. Then your Node.js, or what do you call this one? Node.js. Those who do Python, they call their own Django, right? Django or Java code will be here, right, in the back end. So when somebody enters their name here and they click submit, this back end code picks that name up and stores it inside what? The database for us. Great. So inbound things from the outside internet gets the front end. Then when you get the front end also tries to fetch the details through the back end server connected to what? The MySQL database or whatever database you have. Let's say I log into my Facebook account, right? So me from the internet, I log into my Facebook account. My Facebook account, when it opens, goes to pick my details and then brings it to my front end. Then I now see, so the details get uploaded to the front end. Then I, on the internet, I now see my page. So that's what it means. Let me play it again. Internet, I open my Facebook account. The account goes to load all of my details from the database, brings it back to my front end, and then it shows me everything on my browser. Do you understand that? If it's good, just type good. If it puts everything together in your mind, just type good. Good, 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 great. So that's how all of these things work. But it happens within a second, right? You don't even know all of these things are going on. Okay. So when you're coming for the catch-up session, please bring your pen and paper because you're going to do calculations for the cider and addresses, and then you ask all your questions about cider over there. But today, I don't feel like doing that today. Okay, good, good, good. Now let's play the next animation. So what about outbound, right? So outbound, I think it's almost the same thing. It just goes out, just showing outside. So inbound is really like the tenant explain how we see the web pages that we see. All of these tests will take place. Great. Any questions before we try to run please add the pause button going forward. The video was too fast. Oh, yeah. Sure. I'll add a pause button. But I've already explained it, so you're supposed to go fast. Okay, don't worry. I'll add a button, right? James, you have a question? Let me get you unmuted. So, James, let's go. James Gilbert
Okay.
some more. Yeah.
Yes, sir. So I have
Yes.
two quick questions. So what you just
Okay.
demonstrated, I want to understand what account for either the fast or slow nature when you log online and you enter your details and the pace at which it moves. What influences that, if you could explain a bit? And secondly, I remember during the, I think, orientation or one of those videos, you mentioned something about, you gave an analogy that assuming you are having a supermarket and on a Friday when everybody is coming to, let's say, do business, so the traffic becomes so heavy that the system crash. And you then explain that cloud computing helps you to manage some of those. I have been thinking about, as you were explaining the other areas, how can I get that understanding based on what you just explained to us this one? I don't know whether you get my question.
Okay, so that is also for another session, but I'll just give you a heads up on that. So we have something we call auto scaling. Auto scaling means that we create a server, okay, and attach it to an auto scaling group. A group which says that, see, if you are in this group or when the things in this group, we allow them to multiply in number when the traffic is going becoming higher, right? So all those things are also based on certain metrics. Like when we realize that the CPU utilization on one of the servers is going too high, then we automatically create another server to come and join this server to pull the rope, right? So that the server can win the game. So we allow you to auto scale. We define the limits, maximum, minimum, threshold. So let's say if we are auto scaling and we allow up to about 10 of those instances to be created whenever there's a high traffic. And when there's normal traffic, it will scale back to just one server or two servers. That one is auto scaling. It's something that we also learn how to do, but not today. So we create a server, we add to another scaling group, and then attach certain metrics and define certain metrics for it to auto scale. When there's high traffic, we will auto scale. Then we attach a load balancer. I mentioned load balancer, right? And the load balancer will distribute the traffic to all the many servers. So let's say on a Black Friday, you have the servers move from maybe 2 servers to maybe 20 servers. But there's a load balancer who to now be say, hey, you this traffic, go here, you go here, you go here, you go here. So that it will like evenly distribute all the traffic for the 20 servers. So that 20 servers handle the traffic instead of 2 servers. Then when the Black Friday is over, the number of servers shrink again to just 2. Then now the load balance will now be done just against two servers instead of 20 servers. Have I answered your question?
Yes, sir. Thank you.
So
But the first
yes.
question, you didn't touch on it.
What was the first question?
I was asking that the demonstration you just did, I was thinking about what influences the speed in which when you enter your details online and how you get a response. What influences the speed?
So many things. Number one, your own internet speed is one of them. So your upload, your download speed, you can even check it online. So if your speed is not good, your own internet speed is not good, you get things at a very slow pace, right? And sometimes through the location of those web servers can also be another issue. So if the servers are far away and there's no provision for caching means like trying to create a copy of the same content in a location that is close to you. So you don't have to go to where the main server is, maybe in India or somewhere far away. You can create a cache location, maybe somewhere close in Africa, maybe Nigeria or somewhere, or maybe even in Ghana, you can have some caching service or caching infrastructure so that when somebody asks for a video and a video has already been watched by someone in Ghana, you just point you to where the location of that video is, but it's not try to upload it from all the way from North Korea for you. So sometimes, as I say, it's many factors. So if the design is not good enough, it can slow down. Also, if your own internet speed is bad, you get the content to also slow down. Just know that all of these things are just computers that are connected by a network. So if the computer is just like a road network, right? So if the market is very far away from you, that's what I mean by distance. It takes quite a time before we get the goods on the market and bring it back to you. So when you request for any web page, it takes time to get where the server is and then get it close to you. But let's say if the market is in the northern region, but we've created a smaller branch in Accra, when you need something, you may just go to the branch in Accra and not travel all the way to the northern region, right? And that's what I mean by the caching. So you get the things from, unless some of the items, people don't really buy them in Accra, then you have to now board a flight or travel on a bus all the way to the north to go and get them. But if they are common things, I think the branch in Accra will have them. So that's how we design caches, so that when the things that people request for are like the common stuff, we put them in the cache location. So I don't have to go to where the main server is. But if what you are requesting for is not available in the cache, we call that one the cache miss, then you have to go to the main server. I don't want to go too much into that, but that's the idea. So it's not just one factor, but it's many factors. Hope I've clarified your question.
Thank you very much. Yeah, thank you very much.
Welcome. Some of these technologies, don't worry. See, when you are in the new in the cloud space, they look like they are too much. But with time, they'll just come natural. They'll come natural to you. So yes, all of you just relax. I'm trying to make it as simple as possible, but no worries, with time, all of you become so familiar with these things. Okay, awesome. My time is running out. I have to be fast, else we can't do the next part. Any more questions, or we are all okay with this? Hopefully, I think we are good. Now let's see whether I can bring up my
Questions in
server
the chat box.
in the chat box. Okay.
So I raised my hand.
Your hand is no hand is up. How did you raise your hand? Did you raise it physically? If it's physical, I won't see you.
No, it was in the the lower, like the inside the menu, the Zoom menu. That's what I was asking.
Okay, let me check.
Anyway,
Oh, okay.
yeah. So can I quickly ask?
Yes, go ahead.
Okay, so sir, you see, you were saying something about the web server and the app server and the database.
Yes,
So the
yes.
thing is, some of us, we are not software developers, so like we've not really deployed these kind of things on-prem before. So what I
Okay.
wanted to find out, ideally, does it mean that the back end side, I understand, is basically for maintenance, when maybe the software developers need to maintain or maybe patch their back end or something. But what I want to know, does it mean that anytime you want to do that, you must have a separate IP address for accessing the back end, then also a separate IP address for accessing the front end, which that one is available to the public? That's what I want to understand.
Okay. Who are you talking about? Do you mean the developers or who?
I'm talking about the developers.
Oh, okay. So if the two are hosted on different servers, definitely you have to use like different means to connect to them. So definitely the addresses will not be the same. Definitely won't be the same, whether
But
private or public.
but which one is much more better? Like, is it supposed, can you host all on one server so that
Oh,
it
yes,
will have
yes.
just one IP?
You can do that, but for security reasons, we don't do that, right?
Oh, okay.
Yeah.
Okay.
And the back
All
end,
right.
the back end is not just for patch like maintenance. No, the back end is where the real brain of your software is.
Yeah,
The
yeah.
front end, they're just like colors, so it's just like
Yes,
colorful
sir.
displayed in your browser. But the back
Yeah.
end, that's where the logic, the business logic actually resides,
Yes, sir.
right? The whole system actually resides in the back end. Then we may even separate that back end code on one dedicated server and push the database to another server altogether. So the back end code may not even sit in the same place with the database. It can happen, we can do that. But that when you do that, then you have what we call the two-tier architecture. Front end on one server, back end and database on one server. That's just two-tier. But three-tier architecture, front end on one, the back end code itself on another, then the database also on the third. So that's what we call the three-tier architecture.
Oh, okay. You know, I'm used to on-prem stuff, so I was thinking, I was like,
Okay.
why do you have to divide the whole thing this way? But
I get you.
I
I
get
get
it
you.
now. I get it
Yeah.
now. And
So you
about
mean
my other colleague,
okay.
the caching that you were talking about, I think you made mention of something like edge zones. I wanted to know, is it similar to what he was asking about, like having an edge zone?
Yes, yes. An edge location does that. It does caching.
Oh, okay.
It's
Okay. All
basically
right.
for
Thank you.
it's just a data center that is used for that. Yeah. Okay. Eugene, your hand is up. You can ask your question.
Yeah, sure. I wanted to ask, so with the front end, can you say that it's more of an interfacing between, the net and the server, more of just an interface, or there's much more than interfacing?
When you say interface, what do you mean? I want to understand whether we are on the same page.
Uh, since you're just saying that it's more of a, just like colors, and the real logic goes the the back end. So I was just thinking that, okay, so that's the front end is just like linking you, or yeah, just being like a gateway
So let's
in
say
quotes, just
LinkedIn.
link there.
Yeah. So this page, for instance, this is my old LinkedIn account. Don't send me a request here. But this is so this is for all front. Whatever you see here is front end code.
Yeah,
Whatever you see here is front end code, right? These are all
that's right.
front end code. So the pictures you are seeing,
Somebody's phone is not.
okay. So the pictures you see, all of these things are just front end code, right? Front end. But when you type in your name here, okay, let's say when you make a difference, experience, when you add an experience, right? I want to add an experience here. Maybe Amazon, I work for Amazon, right? Then
Yes.
job title. This is still front end I'm interacting with. But when I finish and I click next, or maybe let me go to next. This thing I've done is going to just make recruiters start messaging me. Okay. I'll teach you guys some of these tricks later. There are ways to get interviews that the people don't know. Okay. Yeah, we are all not the same, right? Okay. So when right now, this is like it has changed here. It is still here. When I refresh this
Okay.
page, it is still persistent. It will still be persistent, right? And it's still persistent over here.
Yeah.
So what does it mean? I only interacted the front end, but when I click submit, back end picks whatever I've done in the front end and it has moved it into the database. So now whenever I refresh, it picks the information from the database through the back end and gives it to me back in the front end again.
Okay.
Yeah. So front end just displays whatever, let me just put it that way. Front end displays all the data that should be displayed in the back end for us. Yes. So some of these pictures, when you even upload a picture, the picture will be stored somewhere on the cloud, and then the link to that picture will be returned to the front end. Then within the front end, there's a space or portion which, as long as you give it any image link, it will display the image for you.
Okay.
So the picture itself is not stored in the browser that you are seeing here. It's stored somewhere. But the link is given to the front end, and browsers are good at opening links, whether it's image link or whatever. Browsers are very good. So all the images or pictures you see here, the pictures per se may not actually be inside here per se, but they are being uploaded from a certain storage somewhere. And that logic is also handled by what? So all those links, if you start up the web page, the back end will provide you all those links to the front end. Yeah. So it persists and holds all of that data. So when you open the front end, everything is looking nice and perfect. Usually the back end logic and front end logic are working together.
Okay.
But that doesn't mean that you need back end before you upload pictures. No. You can still host your pictures somewhere else and just feed the links to the front end. It will still be opened by the browser. But for other information like the things that you actually upload yourself, The one that you upload yourself that you want to see again the next time, those ones will be handled by the backend and database logic. Yeah.
Okay.
Don't worry. Well, maybe one day I'll just let us create a website together. We'll do both front, back, and then database together. Then we'll see how all of this works. Yeah, that will make more sense to this. Okay, first
Okay.
us, last person, and I start the deployment.
Okay, so thank you for the opportunity. Okay,
Sure.
so I'll say currently I'm trying to build a web page and then I'm almost done. But I wanted to ask if it is best advice for the front end and back end to be on one server and then the database to also be on another server.
You want front end and back end to be on one server?
I'm asking if it is advisable that front end and back end should be on one server and then the database to be on another server.
What kind of application are you building?
Actually, it's a school management system I'm trying to build.
And which resources are you using?
Actually, the users are the school administration and then the teachers.
No, I mean the infrastructure you're using. Where is it from?
Come again.
The infrastructure you're using. Well,
Actually,
are you using cloud or you're using your own service or
no. I started building it on my machine using one of the development tools, which is built in, which has AI built in. So I use the expressions to build it up.
Okay, so they do the hosting for you, right?
No, currently I've not hosted it. I will do the hosting myself.
Okay, but they've given you the codes. Are they going to give you the front end, back end?
Yes. The front end has been designed. The back end has also been designed.
Okay, and they so I'm just thinking, but usually that's not an architecture that I'll go for.
Okay, so basically
but I think it is a common architecture too. It is common. So
okay.
definitely the database should definitely be on a private. So you can go for that. Since I don't think you are planning for 3-tier architecture. No. So you can go for that.
Okay.
Yeah.
All right.
It's fine.
Hello, please, can I contribute to this?
Sure.
Okay, so there are styles of programming like the full stack, right? So for the full stack, you're able to create your back end and then your database separate, and then the front end separate, then you call them in classes. But in some of the programming styles, you can mix both the logics and then the HTML in the same code, like in the same front end, and then separate the database. So I think with this question, when you have such a code that, let's say, your logics and then your HTML are in the same file components, and then your database is also in a different component, is it advisable to use like the public for the front end and then the logics and then the private for the database?
Wait, are you also asking another question?
Yeah, like the follow-up to what he said. Like
I thought you were actually contributing to what? I thought you were making.
I think what I wanted to ask is what he has made it clear.
Okay.
It's a
So I think
contribution.
you're okay now. Sure. Yeah, so as I said, it depends on the architecture. That's why I was asking questions about how you are building it and where the code size, stuff like that. So it depends on the architecture that you've already begun with, right? So if you have built, but see, back-end code mixed up with front-end code. See, the two codes will not be mixed up. I'm not a senior software engineer, right? But I've done a lot of software engineering before. But from what I have seen so far, you cannot bake back-end and front-end code together. I don't know the stack you are using, so I'll not comment too much. But if I'm using a normal Node.js, JavaScript, HTML, CSS, or even React application or what have you, still back-end will be separate from front-end code. You don't mix the two codes together, right? So in that case, and whenever I'm developing an application like that, I do all of that on my laptop. So on my laptop, I can simulate database backend, front end. And in that case, I'm actually doing them all on one server input. But when you are going to production or you're going to expose it to the public to use, that's when you want to now bring in the security measures. So that if possible, you can separate the back end from the front end, so that the back end will be on the private and the front end will be on public. So that only the front end server has access to the back end server to pick up things on the database. So that not so that no one can hack you anyhow, right? No one can just hack your backend code or database code. See, there are ways of hacking code, so many ways, right? But the best architecture is to have both of these things in the private. Then you make it more difficult for hackers to hack your code. But if you think the solution you are building is not really like something that will attract hackers, fine. You can just go for something that works for you. But your database, of course, that one, you may always want to keep it private. So that's a simple advice I can give towards that. I hope it's clear. Okay. This is what happens all the time I try to log into this place. So the catch-ups, this week I have to take a flight somewhere a little far away. So when you don't see me the catch-up, I'll let one of my assistants, okay, meet you in the catch-up session, and maybe I'll give them an advanced demo to do with you. I'll give them an advanced demo to do it. So make sure you don't miss this week's catch-up. Just make sure you don't miss it. Okay, we have some few more minutes. Let me see what I can do, one quick one before we go. I hope you can all see my screen. Team,
Yes,
can you
sir.
see my screen?
Yes, sir. Your screen is visible. Yes, sir.
Okay. So this is what I'm going to walk you guys through
Yes,
right
sir.
now. We are going to do it step by step, okay? When I finish, I'll share this with you, so you can also do it on your own. What I wanted to do right now was to just put us into breakout groups, but it's going to waste time. So what are we going to do today? I don't know what I can even use 30 minutes to do this, but if you don't ask questions, I can do that. So first one, you need an AWS account, right? And what we are just going to build one custom VPC, 2 subnets, 1 internet gateway, create a security group, a Bashian host, or we call it the Jumpbox, right? Bashian host means that we are going to create one server inside a private subnet. And the server in the private subnet, no one should be able to access it. But we'll place another server inside the public subnet, and that's what we will call the Jumpbox or the Bashian host. Now we'll give connection access between the private and public, right? So that if you're able to get inside this Bashian host, it means we can now log into the private or connect to the private server and see what is inside it. If you all remember, we've created EC2 servers before so many times. When we finished creating the server, what do? We just opened it on Instance Connect and we saw and we were typing some Linux commands, right? So that's what we're going to do. We'll try to make sure that this one is not easy to access, right? With what we call the SSH connection. It all sounds so much till we just start building it ourselves. So this architecture is very simple. Maybe this one looks complex, but it's this simple. Public subnet, private subnet, 2 computers, 1 in the private, 1 in the public. Then no one can access the private computer except the person who is able to access the public computer, which we call the Bashian host. This is all we want to build. Okay. Are you ready? If you're ready, I'm ready. Are you ready?
Sir, please, can you explain what you just explained again, please? I beg.
No, we are going to build it.
Okay.
So the explanation will be in the building. Let me move that away from the screen. So as I'm building, I'll be explaining, right? So don't worry. Else, we won't start at all. So what the first thing we need to do? What the first thing we need to do? Okay, so let's just get started. Right now, let me find my current IP address. What's my IP? So we're going to go to this site. What is my IP? So my IP address is 41.155.13.104. Okay. Now, the reason why I'm finding my IP address is that I'm going to allow only my IP address to be able to get inside the public server, right? every other person I'll prevent from getting inside the public server. And that's how we use the Jumpbox. So the Jumpbox just creates or reduces the attack surface, because the Jumpbox is our only way of getting inside the private network, right? Let me, no thanks. I have to beg the other people to give us more time so that we can finish this. Let me draw this for you to see again one more time. I have another class at exactly 3 o'clock, but I'll beg them to give us a little time. So the public subnet, okay, and then the private one. The server in the private one, right? No one can ever access it. But we are only giving one person the ability to access it. This is this person called the Jumpbox. And it's also another server. So if I am at home on my laptop, I want to even restrict my laptop so that it's only my laptop that is allowed to connect to this server, which is in the public. Even though it's in the public, yet we want to still reduce the attack surface. So when you are in your house and you want to access my database server, this one, I won't allow you to access it, or there's no way by which you can access it directly. Forget about it. Directly, there's no direct connection. The only connection that is possible is through this Bayesian host connection here, this public subnet. But even with the public subnet, I have still reduced the attack surface again, so that's why I'm finding my IP address, so that I'll allow only my IP address to be the one who can connect to this server. So this is just a chain of thought. Then once I get inside this server, between these two servers too, I'm only going to allow this server. So my laptop cannot even connect to the database straight away. The only server that can connect to the database is this public server over here, the Bayesian host or the Jumpbox. So once I get inside this one, so I'll do what we call the SSH into this server. When I get inside this server, then I'll do another SSH. SSH is just a connection, right, into the database. That's the whole idea. Do we get it? If you get it, test type good. If you don't get it, I'll explain it. Maybe this one I have to explain before I start. Okay, good. So let me just try and create the resources. If I even create them and we can't test it today, fine. We'll test it in the catch-up. So as I said, my traveling, I have to confirm it by Tuesday. If I don't go, then I'll do it myself. If I do go, I'll give them access and they'll do it to you. Okay, so let's see. So let's do this now. So I know my IP address, my private address. So now when you want to look for any service in AWS, you have to just search for it, right? Let me put this one somewhere. Okay. So I'm already logged in, and then the first step is we need to create our VPC. So let's search for VPC here, VPC. And I click on VPC. Okay, so the service has opened for us. So we want to create our own VPC. These things, they cost money. So if you're not a free tier, just be careful. Okay, good. Now VPC, we have two ways of creating a VPC. Right? We have VPC only. If I go VPC only, we'll spend a lot of time here. So this one, I'll create a VPC and I'll provision the NAT gateway, the internet gateway, the route tables. I'll do everything manual myself. Which one do you want me to do? If I go for this one, VPC and more. With VPC and more, this that already just builds all the connections for you, right? So if you want the things to be done quickly, you just go for VPC and more. Guys, vote and let me see what I have to do. In the chat, do you want manual or you want that to be VPC and more? Nobody cares what you do. If you have done it. You are there manual, but you are all driving automatic cars. Okay. Yeah, I'm just thinking of the time and time and time. The one man, don't worry, if you don't finish, we'll continue later. So VPC and more. So you can see that the subnets are 4, right? So here you can change the number of subnets. Okay, you can just do 1. So 2 subnets. We can use one as the private, one as the what? Public, right? So these are 2 subnets, one as private, one as public. Then the route tables are already attached to it for us. You get it? Then we just have to go into the route tables and go and make the configurations and connect it to what? Now, if I scroll even to this side, now you can see that the public subnet, okay, is connected to what? The internet gateway for us. All right. Then this one will be our private subnet. And that's run route table. And then it just has internal connection, right? But we can attach a NAT gateway to it. Okay. They want manual. Okay, many of you are just saying manual. Let me just go the manual route. Great. Now, what name do we give to our network? Okay, let me just say cloud with Shadrach, right? This is our VPC. Okay. And the CIDR block range, we'll just use what we choose, right? 10.0.0.0/16. IP version 6, no. We're not talking about version 6, so let's just stay there.
The 0 is left with 1.
Hey, it would have brought it for us. Okay. Then we'll just create all available. Let me see. Encryption, non-default tenancy. Okay, this okay. Let's just create it. So as easy as that, we have created the VPC. Okay. Now let me move this one from here. Now if you look at the left side, do you see subnet over here? So I click on the subnets. And I click on, we want to create. So these are the available ones, the default ones, but I want to create a subnet. So I'll select my VPC and I'm choosing cloud with Shadrach, right? Okay. Then my subnet name, what do we call the subnet name? The subnet. So let's call it cloud with Shadrach. So this will be our public subnet. Public subnet. And then availability zone, let's put it on the US East 1A, okay? So that's the easy, that big box before we create the subnets, okay? So US East 1A, then the CIDR block, so subnet CIDR block, the 10 dot, let's just go with 25, so 10.0.0.1, since I'm splitting it into 2, so 10.0.0.0/24. 1, 2, 3, 4. Perfect. Okay. Then what else? I think that's all. That's all. So let me create this subnet. Let me check cloud with shared public subnet. Then US is 1A. This is the CIDR block for the VPC/16. For the subnet, we are using /24. Okay, great. So this is our first subnet. Let's create one more. So cloud with shared VPC. Subnet name, let's call this one cloud with shared private. Then, yeah, availability zone, let's choose, let's put it on the same subnet, right? US is 1A, the same is availability zone. We are just using one box for the two. Then the cider block will be a little different. So this is this
Is it off?
guys, sorry, I went off. Okay, I'm back. This is my screen.
Yes, we see it.
Okay, good. So when the internet went off, I think the declaration failed. Let me retry again. Okay, it now worked. So we have two subnets. One will be our public and one will be our private. So currently, the subnets will both look the same. Let me go to my VPCs. So cloud with Shadrach, this is a VPC. Okay. So resource map will show us what we have currently. So this is the VPC we created. This is beginning to look like what we had, right? So the private subnets and then the public subnets. Okay. What's next? Who can tell me what's next? What do we create next? Those who say manual, what is next? Okay, we don't want to
I
talk.
think a private subnet.
Routing
Or
cable.
What did he say? Just put in the chat. Let me see the chat. Internet gateway, yeah, right. We are going to create our internet gateway. So let's come here. Virtual private cloud, internet gateways. And then we want to create one. We want to create an internet gateway. What should we call it? Let them give it the same cloud with shard, right? Cloud with shard. Guys, please see my screen. I should make it bigger. I think some people were complaining about this the other time. Let me make it bigger. I hope it's better now. So cloud with shard.
yes, it is.
Okay, internet gateway. So you see all of these things, AWS makes it so easy to create them. Just clicking buttons here and there. That's all, nothing strange. So you just create this internet gateway. Okay. So right now you see attached to VPC, right? So I click on the attach to VPC at the top here. Then let's select our VPC, Cloud with Shard VPC, and we just add attach this internet gateway. So what we are doing right now is we are just going to our plot of land. We've gone with the one who is selling the real estate land to us, and we've told the person we want this area. We want this area of land to buy, right? So the VPC we have created is just the area of land we want to buy. And they have shown us where the land is. So the VPC we have created is just the land. There's nothing on it, right? Then we went to an architect and we told the architect, see, I want to create two major areas in this place, the public area and the private area. That's what we did by creating the public subnet and then the private subnet. That's what we basically did. Then we asked him that, see, this whole land, there's no gate. So that's why we want to create the internet gateway and attach to it. And that's where we are right now. Any questions? Right now, I'm going to use the chat because of time. If you have questions, just put it in the chat. Okay, so we can now go back and look at our VPC. So let me just duplicate the screen. And then I'm going to your VPCs. So Cloud with Shard VPC. And this is what we have right now. Okay. So we have attached the internet gateway, but we don't see it here, right? We don't see it here. Why don't we see it here? Then we have to go and work on it. Okay. So let me go to VPCs again. So now the state is what? Attached. So right now we have attached the VPC to our, the internet gateway to our VPC. Okay. So on the exam, one of the tricks that they may ask, the developer land an EC2 instance with the public IP address, but cannot connect to the internet, right? And what the most likely cause? Obviously, because there's no internet gateway. Okay, great. Now let's try and configure our route tables, right? Let's try and configure our route tables. So we are going to go to route tables, and then when we do that, we will now get the connection to the internet gateway done for us. Okay, so route tables. Let me minimize this one. I can't see anything. If you have a question, just put in the chat. I'll see it. Class prefect, are you here? I think he's supposed to be here. So I go to route tables over here. And then let's create our route table. So I'm creating a route table, and I'll call this route table class with shard public route table. Okay. The VPC, I'll attach it to our cloud with shard VPC. Great. And I'll go to click create route table. Okay. Now this way we're going to edit the route and put in the rules I spoke about, right? Okay. So currently the target is local. So right now this route table enables us to communicate within the VPC. But we need to add some more route, especially adding a route for us to be able to communicate with the external internet. Let's click on the add route. Right now, the add route, the destination is to the external internet is what? 0000, right? I mentioned this one already. And when it's going to 0000, which device should it target? What should I choose? Let me check the chat. Internet gateway, yeah. So someone asked, the internet gateway, will it give internet access to private and public? Yes. It is what enables the whole VPC to even have internet. But as whether it will direct connection to the internet gateway or whether you connect through the NAT gateway, that one will come to that. So public is direct, but private, they have to connect through the private NAT. That is the NAT gateway. So the target over here, I have to choose what? Internet gateway, right? Okay. And which internet gateway? The cloud with Shadrach internet gateway. Great. Then basically I have to see these changes. So what I'm saying is that this public route table, okay, the entry I created for our public subnets, okay, whenever anybody is going to the internet, it should just brand the person to the internet gateway. And this is how the rules look like. Very, very simple, nothing more. So I'll just save these changes. Okay. Great. Now, I've created a route table, but this route table has not been attached to any particular subnet. We know very well that we want to attach this route table to what? The public subnet, right? So I'll go to edit subnet association, right? Then which of the two am I attaching it to? Obviously the public, right? Any questions on that? Any questions? Oh, I've muted all of you, sorry. If you have a question, please raise your hand and then I'll let you do that. Ask your question. Then I'll click on save associations. Okay, now let me go and look at my VPC again. Let me refresh here. Great. Now let's look at it. Now, our public subnet has a connection with what? The public route table. And the public route table connects our public subnet with what? The internet gateway. So right now we are sure to have internet connection within this land, on this plot of land. Good. If it's good, type good in the chat and let's continue. Okay. Great. Everybody's saying good. Now, what do we do next? We have to now create a security group, right? For the protection of our instances, the instance we are going to be launching, or the servers we are going to be launching, we have to create a security group before we even place the server or attach that security group to the particular server, right? So the security group, as I said, is a security guy at your house, which gives people access to the things in your house or to enter your home or not to enter. So security group is just here. When you look at security, look on security groups over here. So we are creating everything on ourselves. So I'll create a security group. I'll call this security group at cloud with shard. This is a recording, so guys, don't worry. If I'm going too fast, you can just slow the recording when you are doing it yourself. So this security group is going to be for my Bashian server, right? Bashian security group. Okay. I don't have to put any description over here. The VPC is a cloud with shard VPC, right? This one. Okay, then I'll add an inbound rule. Inbound rule means who can access this server and how can they access. So as I said, we're going to be using SSH, right? Secure shell connection to this server. So I'll choose SSH. Then SSH. So my IP address, I want it to SSH for my IP. And this is my IP address. Let me check whether it's correct. 41.155.13. Yeah, this is my IP address. 131.104. So the only person who can do SSH into this server is who? It's me, my IP address. Right? That's the only person who can do. So you can go for custom. Custom to you just have to type. When I select custom, I just have to type this thing over here. But AWS has a way of automatically detecting your IP address. I can just type it here and put /32, right? But when I just choose my IP address, AWS will just fill it for me automatically. Okay. Then description, you can add on the home laptop to Bashian. You can type, you may not type, it doesn't matter. So I'll just go to what? Add rule. So I've added this inbound rule, which allows myself to be the only one who can connect to the Bashian host server. Then, so we've added me being able to connect with the Bashian host server. Then what else? Yeah, I think that's all I have to do. That's all I have to do. Okay, so we are okay with that. I can SSH here. So I click on create security group. As I said, CIDR block, security group ID or preface list has to be specified. Did I add this one? No, let me delete this one. I don't need this one. So create security group. Oh, in the description. So allow SSH from laptop to machine. Create security group. Okay. So that's that. I've created my security group. So when I create my server or deploy my server, I can just attach this created security group to it. Now, for the private server too, I want to create a security group for it. And what I'll do is that I mentioned something earlier. Let me just go over that. I mentioned that I want to be able to allow these two subnets to communicate, right? So my Bashian server is here in the public. I'll put a security group around it. This is my security group. When I put the database server also here, I also want to place a security group around it. So this will be security group 1, security group what? 2. So in the inbound rules of security group 2, all that I'll say is that inbound, the only people who can inbound into this server here, server 2 is. So I'll just use security group 1. This is a funny way of allowing access to another server. I'll just say allow inbound security group 1 to this server. So when I'm creating security group 2, the inbound rule, I will not use my laptop. I'll just use the name of this one. So, which means that anybody who has this security group or anybody in this security group can access the database server. So that's why I'll create another security group called security group 2, right? Which allows security group 1 members to communicate with the security group 2 members. As I said, don't worry, if you don't understand this, I'll go over it again. These are just electrotechnical things that I'm trying to do today, right? So nobody should be angry with me. I know right now all the ladies are smiling. Everybody's happy with me, right? If you're happy with me, just type happy in the chat. If you're not happy, please type happy. We were 90, right now we are 81. It means 9 people got angry and they left. Please don't leave. Don't get angry and leave. Okay. Are we ready to create security group 2? So create security group. This security group is for what? The private server, right? So I call cloud with shard. Private what? Security group. Okay. Description, SSH access from Bashian, right? Bashian security group only. VPC is still my VPC, cloud with shard, right? Our time is up, I know. We'll be done soon. Okay, don't worry, we'll be done soon. Someone said we went beyond 100. What's went beyond 100? Okay. Then I've already chosen that. Then I will create security group. Let me just add the inbound rule before I even create. Add inbound rule. So the inbound rule I'm adding, okay, it's a very simple rule I want to add, right? The type will be what? SSH. The type will be SSH. Then the source. I want to make the source what? A custom source. Right? So the port SSH is port 22. Now the source, hold on, I want to set this. Let me search. So I'm going to search, and the search is that, what I'm doing is that I want to just allow the security group 1 people to connect or to do inbound. And the only person obviously in security group 1 is who? Is the Bashian host, right? So he should be the only person who can connect. So over here, you can see it here. So cloud with shard Bashian, this security group, you can allow a security group. So anybody within the security group can do SSH into the private database. Description, I don't need one here. And that's all. Create security group. Okay, good. So right now, we have completed our demarcation of the land. The only thing we have to do now, right now, is just to put in the EC2 servers. But before we do that, let's go look at our VPC now. So I'll go to VPC, and I go to, where is it? Your VPCs, I come here. Let's check all that we've done so far. Maybe I can even end here. Here in catch-up session, we continue by building our house. Right now, we've demarcated the land and created our fences. So the only thing now is just build our houses into those demarcated areas. Then we'll see whether people can connect or not connect. And we'll see whether our security that we've defined is good or not good, right? We'll see. So currently, where's my VPC? So this is my VPC. Let me open it. And let me look at my resource map, right? So this is my VPC. So currently, this is what we've done so far. Public subnet, private subnet, Public is connected to what? The public route table connected to internet gateway. Private subnet also connected to what? Private route table. Currently, we've not added any NAT gateway, so it's not connected to the internet. Fine. Maybe currently we don't need it to have internet connection, but later on we can give it. So that's all we've done so far. So to recap, hold on, let me recap. I want to use a drawing to recap. Who's drawing? My drawing skills is not so great, but I want to use a drawing. Good. Let me use this space as my drawing board. So right now, this is what we have. Guys, let's focus. We have our VPC, our plot of land. Then we have 2 subnets inside our plot of land. Hey, why is my drawing skills degrading so much like that? So we have the private, we have the public or private. And the only thing we've done so far is that this is imaginary. We have created a security group here, right? Let's call it security group 1. And we've created another one, imaginary, right? We will attach it to the VPC, to EC2 where we create the server. So this security group what? 2. And we are saying that if you are coming here and you are in security group 1, you can access members of security group 2. This is what we have defined. And also, the only one who can access security group 1 should be what? My laptop. This is all we've done so far. Currently, there are no servers. So I'm now going to create the server inside here. The public server and then the private what? Server. So as I said previously, when we were creating these EC2 servers, we never mentioned VPC or subnet. We didn't even pay attention to any of those things. I asked you guys to just forget about it. We're just creating the servers anyhow we want. But right now, we have secured our land. We have secured our network before we even deploy servers into the network. And it's a standard practice. You don't just start deploying servers anyhow, but secure the network before you now deploy servers into the network. Good. Any questions on this? I may just end here. We'll continue the catch-up. This is all we have done so far. Any questions? Let me unmute everyone. If you have a question, you can raise your hand. Team, you have a question, raise your hand. I know my time is up. Don't get angry with me. Okay. One person has raised their hand. Hold on. My participant list, I can't even find it anymore. Hold on, I'm coming. Okay, hold on. Okay, it went to hide somewhere, and I'm now putting it up. Good. Okay, good. I'm unmuted. So someone go for it. Ask a
I
question.
think when you were doing your drawing, you forgot to add the internet gateway, but I think that's fine since we already understand.
Yeah.
But the place that I got a little bit confused, just a little bit, was when you were talking about the security group, you
Okay.
said that it has to do with stateful connections. So I was wondering why I thought stateful means that it remembers the connection.
Those who come in. So you see that we only gave connections. We only describe those who are coming in, right? The
Yes.
inbound rules, yeah.
Okay. So you still have to configure it regardless, even though it has a function that it remembers connection. You still need to configure it that it should only allow your IP address to access it.
So stateful means it can remember, but that doesn't mean that everybody should come in, right? So even though it remembers the people who are allowed to come in.
Okay.
So when you get inside the house, it remembers you have come into the house. But if you are not on the list, if you're not on part of the inbound people, it don't even allow you to enter the house.
Oh, okay.
But once you've gotten inside the house, it remembers that you are in the house. Other than that,
I
somebody
don't
can
know.
just jump the wall and try to come out of the house. You'll be like, hey, you, I didn't allow you in. Where are you coming from? Do you get it? So,
I don't know. It's
yeah.
kind of getting closer. The meaning is kind of getting closer to what NAT actually does. But I think it's just a little bit different.
Yes.
Yeah. Okay. Thank you.
Welcome. How many of you feel like the weather is becoming hotter inside this class? If you feel like it's becoming hotter, let me know. Just give me feedback. Don't worry, I won't continue. Today, I won't continue. I'll just end here.
I'm
If you
lost.
think the weather is becoming hot, just type hot in there.
Very, very.
But you both say you were happy, so how come it's becoming hot? Or you are happy and the weather is becoming hot with your happiness? Okay, very, very hot. Hey, please, don't worry. I'll bring AC in the catch-up. Don't worry. When I'm going to catch up, I'll bring AC.
I'm lost, but I think my group will sort me out.
Sharp. And the recordings too are there.
Hello, sir.
Recordings are there. Yes, sir.
Please, for me, I have not been following through from, I think, the first two classes. But then last week and this week, I have followed it up, and I'm really getting a lot of stuff. But I want to ask, with some of the classes that I am doing, I think generative AI and then some others, we have a Google Classroom where we have the recordings and then assignments and all of that. I don't know if cloud
Google
computing
Drive.
also have something of that.
Do you mean Google Drive or Google Classroom?
Well, with generative AI's Classroom, it's Google Classroom.
Okay.
You go there, you see the what have you posted there, and then the assignments and all of that. Then we do it. Because I think with all that is happening, if you have been able to do it, we can also do it. Just like God was telling us some few hours ago. I think what is needed now is time for us to sit down with the recordings, go over and over again, and I think that we'll pick it up. So we'll need the recordings and all of.
No, the recordings, they are available. So that's what I wanted to confirm. So ask your group members, okay? They will give you the links to the recordings. With the Google Classroom, my assistant will be joining us soon. So he's the one who will be working on the assignment and all those other stuff for me. So when he joins, then you will see the classroom also active.
Right. Thank you, sir.
Yes. Thank you, too. Okay, team, my time is up. Unfortunately, my time is up. So just go over everything. I'll give you notes as I promised. I'll give you notes on all of this. And this week too, there's a project work for your groups to work on. But I'm thinking of, should I maybe push the project to next week, since I have not even finished this first classroom project with you? So it's two things. It's two things. Yeah, maybe I'll just push it to next week and give you guys just an objective test to do.
Yes, sir. Okay.
Hey. Sure.
The thing is, we have to try our hands on the classroom project first before we'll be able to do the project.
Sure. Okay, team.
If I said who are lost, we'll be lost more than what we are losing now.
Sure. I understand. Okay, this way I'll end the recording. Hopefully, we'll continue within the catch-up. Take care.